Hello, my name is Christina Monakova, and last summer I interned at the Marshall Space Flight Center, and this was my project. I worked in the Flight Robotics Laboratory to develop a testing platform for future robotic satellite servicing demonstrations, addressing the need for an easy-to-use controller for complex robotic arm systems. I worked on designing an intuitive controller for an 11-degree freedom human-like robotic arm. But to do this, I first needed a way to test out my controller and control algorithms without damaging the lab's expensive arm. Simulink provided the perfect solution. I imported a CAD model of the robotic arm I was using into Simulink using SimMechanics Link, added revolute joints, rigid transforms, and constraints until the SimMechanics model matched the lab's physical arm. I was able to directly control the torque input to each arm joint and control this torque signal using a PID controller, which I then optimized. Once this was finished, I was able to manually control the arm simulation via angle inputs to demonstrate functionality. Then, to get a little fancier, I added an Xbox input via Simulink's joystick block and controlled the robotic arm in real time like a video game. Once this basic functionality was demonstrated, I jumped into the meat of my project. I designed a glove controller with cheap commercial off-the-shelf parts, mostly from SparkFun. I used flex sensors for finger motion capture and an IMU to determine position and orientation, as well as an XP for wireless control. All of this was dumped into Simulink via the query instrument block and used to control the arm simulation in real time. After playing around a little bit with sensor filtering and calibration, the glove controller worked. Next, an inverse kinematics controller will be incorporated via a Simulink function block to improve the arm control. Also, a common filter will be added to improve state estimation from the noisy sensors, and the arm simulation will be further optimized using Simulink's design optimization toolbox. Simulink not only lent a hand, but armed this entire project, allowing me to build a dynamic virtual reality testbed for a robotic arm from scratch.